Hello everyone and welcome to this video. Today we are going to dive into building a basic messaging system using Apache Kafka. We will learn how to set up a Kafka producer to send a message and a consumer to receive them. We will walk through the process step by step, including writing the actual code for both components. And by the end of this video, you will have a solid understanding of how to implement a simple messaging system using Kafka. So let's get started. Before we move towards the code, we need to make sure that Kafka and Zookeeper are running, as Kafka depends on Zookeeper to manage its cluster state. Zookeeper-server-start.sh space $kafka_config/zookeeper.properties. Enter. While Zookeeper is start, now let's start Kafka server in new terminal. Kafka-server-start.sh space $Kafka_1 /config/server.properties. Okay, now Zookeeper and Kafka running. We are ready to write our producer code. Now let's start with our Kafka producer. I will explain each part as we go along, so follow along in the code. Let's start by importing the necessary libraries to create our Kafka producer. Here, Kafka producer is the class we will use to create our producer instance, which will connect to our Kafka server and allow us to send messages. We will also import a time so that we can add delays when sending multiple messages, making our simulation more realistic.
To create our producer, we call Kafka producer and pass in configuration.bootstrap_servers. Tell the producer where to find the Kafka broker. We are using localhost here for local testing. Hack set to all. Make sure Kafka waits for all replicas to acknowledge the message. This increases reliability. Retries equals to 3 specifies that the producer should retry sending message up to 3 times if it encounters an error. Finally, we set key serializer and value serializer to str.encode, which will convert our keys and values into byte string as Kafka requires.
Now let's create function called sendMessage that will handle sending messages to a Kafka topic. This function takes a 3 argument, topic, key and value. The topic specifies the Kafka topic to which we want to send the message, and the key allows us to identify our partition messages, and the value contains the actual message content. Inside the function, we wrap the code in a try block to catch any potential error during message sending. First, we call producer.send function with our topic, key and value, and then use producer.send flush function to ensure any buffered messages are sent immediately without delay. If the message is successfully sent, we print the confirmation indicating the topic and the message value. However, if an error occurs, it's captured in the except block and we print an error message. And this function structure allows us to keep the main code clean and makes it easy to send messages by simply calling send message function with the required argument. Now let's write a main section of our code. We define the process that will send a few example messages to our Kafka topic. We ensure that this code only runs when the script is executed directly. Make it safe to import the function without triggering a message sending process. We start by specifying the topic name and microservice communication, which is the Kafka topic our message will be sent. Next, we set up a loop and send 5 messages in sequence. For each message, we call send a message function with our topic name and a unique key, where I represent the loop index and a value containing a custom message hello from producer. After each message is sent, time.sleep function adds 1 second delay before the next message is sent and creating a small interval between message for demonstrating purposes. And finally, we call producer.close function to close the producer is properly closed after all messages are sent, which also frees up any resources it was using. Now let's execute this code. Now that we have executed the Kafka producer code, here each line confirms that a message has been successfully sent to the microservice communication topic in Kafka. What we are showing here is how the producer works to send that data to Kafka topic, specifically how we can dynamically send messages with unique key and value. You can see that for each iteration and the message is labeled with a number. For example, hello from producer 0, hello from producer 1, showing that we are sending the multiple messages in sequence. By executing this producer code, we are demonstrating how to create simple message passing system using Kafka, where each message is timestamped and sent to a topic. This the console output serves as a confirmation that the Kafka producer is functioning as intended and that each message has been successfully delivered to Kafka for consumption by other services or system. And the key takeaway here is that we are sending message in real time to Kafka and the message are logged to show their successful transmission. This forms the foundation for building a scalable real-time system that can communicate via Kafka. Now that we have set up the producer, let's write the consumer code that will read message from this topic. Here we first import the Kafka consumer class. We then configure our consumer by creating an instance of Kafka consumer and passing in several key parameters. The first argument, microservice communication, is the name of the topic we want to subscribe to, which should match the topic our producer is sending message to. Next, we specify bootstrap _ service equals to localhost :9092 to connect our local Kafka broker. And the group ID is set to microservice group, which assign our consumer to a group, allowing Kafka to balance message across multiple consumers if needed. Setting auto offset reset equals to earliest tells Kafka to start reading from the beginning of the topic. If there is no previous offset saved, ensuring we don't miss any messages. And the enable auto commit equals to true parameter enables automatic offset tracking. So Kafka will automatically mark messages as processed once read. And finally, we use key deserializer and value deserializer to decode the message from byte string into a UTF-8 string, making them readable by our application. And the key deserializer and the value deserializer converts each message's key and value into a standard string. With this configuration, our consumer is ready to start reading messages from the topics. Now let's define a function called consume message function to handle the process of reading messages from our Kafka topic. This function uses a try block to manage potential errors during message consumption. Inside the try block, we use for loop to iterate over messages in the consumer, which is configured to listen to the microservice communication topic. For each message, we use print function to display the received messages value and key in the console, giving us real-time feedback on the messages as they are consumed. If any errors occurs during this process, they are caught in the except block, where we print an error message using print function. This ensures that receives notification if any issues arise during the message consumption. Consume message function encapsulates the message reading logic, making it easy to start consuming messages simply by calling this function in the main section of our code. Now at last, write the main function for our code. Here we ensure that this code only runs when the script is executed directly and not when it's imported as a module. Within this block, we call the consume function to start reading message from the Kafka topic. This function will continuously consume message as long as there are messages available in the topic. Once all the messages are consumed, or if the consumer is stopped, we call consumer.close function to cleanly close the consumer connection and release any resources it was using. This ensures that our consumer stop gracefully after it finishing consuming the messages. So let's execute this code as well. Now that we have executed both the Kafka producer and the consumer code, let's walk through what's happening and what we are demonstrating with this project. Our consumer is listening to the same microservice communication topic. This is our output. Here the consumer is receiving and printing the messages it consumed from the Kafka topic. And each message shows the content hello from producer and the associate key confirming that the consumer is properly reading the message sent by the producer. What we are trying to show you with this project is a fundamental real-time messaging system and using Kafka. The producer sends message to Kafka and the consumer receives them, allowing for a seamless message passing mechanism between different parts of a system. This setup forms core of many distributed applications where one component generates data or event and another component processes that data in real time. By executing both producer and consumer, we have demonstrated how Kafka enables efficient real-time communication across distributed systems. So thanks for watching. See you in the next video with next topic.